If I have a glass rod, as I have here, and I rub it, then it gets this positive charge that we just discussed. So here is this rod, and I rub it with some silk, and it will get positively charged. What happens now to an object that I bring close to this rod? And I will start off with taking a conductor. And the reason why I choose a conductor is that conductors have a small fraction of their electrons which are not bound to atoms, but which can freely move around in the conductor. That's characteristic for a conductor, for metals. That's not the case with non-conductors. There all electrons are fixed to individual atoms. So here we have a certain fraction of electrons that can wander around. What's going to happen that the electrons want to be attracted by these positive charges. Plus and minus attract each other. And so some of these electrons which can freely move will move in this direction, and so the plus charges stay behind. This process we call induction. You get sort of a polarization, you get a charge division. It's a very small effect. Perhaps only 1 in 10 to the 13 electrons that was originally here will end up here, but that's all it takes. So we get a polarization, and we get a little bit more negative charge on the right side than we have on the left side. And so what's going to happen is, since the attraction between these two will be stronger than the repelling force between these two, because the distance is smaller, and Franklin had already noticed, the shorter the distance, the stronger the force. What will happen is that if this object is free to move, it will move towards this rod.